So I'm going to talk about like a project that I had like last year, I think. So I wanted to play like video games and learn Japanese at the same time. So I saw like reverse engineering this game that you probably know. It's like 20-year-old and it's like a pretty famous RPG. It's Final Fantasy VII. And so the thing is actually like the it looks more like this actually, like, and we have like awesome graphics and all these like weird symbols. So yeah, we're going to look at that, and the other tool we're going to use for that is like a powerful debugger. I didn't make it, but it's just like useful and little like cluttered. But yeah. We're going to do some disassembly with Radare or Radar 2, which is like a command line like disassembler that's free and really sweet. And the last tool of the day is called Wikichan, which is like kind of like an online dictionary. The idea is it's an add-on for Firefox, and when you click on a word, it's going to pop up some like definition of the word you're looking at. So what's the objective of this project? It's let's take the text out of the game and pipe them into like a web page, so that we can use Wikichan to like look up words while playing. And it's different than like just like Google translating, because you can click on the words and directly know what is the meaning of that word, as opposed to just translating everything and not kind of losing the meaning of each individual word, which is not great if you're trying to learn Japanese. So actually, I'm not the first one coming with this idea, and I find like inspiration in this project, which is actually pretty similar, but the guy did that on like PC using Wine, and the same then it was like Firefox and Wikichan. And I wanted to do it for Final Fantasy VII, and I picked like the PlayStation version running in an emulator, because I mean the guy did already the work on Windows, so it's not that fun. And yeah, it was just like an interesting like platform to like explore. So the goals for like today's presentation is, first of all, to have fun, because I mean we're not going to change the world with that, but if we can have some fun while doing it, that's cool. I'm going to try to like show you like a few like MIPS stuff, and maybe give you some Japanese like pointers as well, or something. And I think the most important for me is if I had this project and I set my goal to like solve that, and it wasn't that hard. And what I really want to share is, if you come up with like an idea, you can work on it and power through it, and eventually like it happens, and it's not as hard as it seems in the first place. So yeah, I just want to say that people, if you have like an idea, like go for it and work on it, and that's it. So the plan is we're going to find like the text in memory, and we need to figure out like how to get it out, and then like pipe it into like a web page or something, so we can like use Wikichan as a dictionary. So where's the text? So that's the beginning of the game. Like on the left, like the guy's asking, "Oh, I don't think I've heard your name. What's your name?" And then you have a screen that says, "What name do you want to have?" And then he say on the right side, it says, "Oh, I'm blah blah blah." So what can we do with that? I think like information security people like to fill like buffers with A's. So we can be like, "Oh, I'm A. That's cool." So we can do that. And then because it's running in an emulator, we can take like a snapshot of the RAM. And then let's do the same, but with B's, and like B, 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 B. Okay, so I don't know if you see where I'm going with that, but the next step is we're going to diff the two different like snapshots that we took, and we're going to see what changed. So if you look at that, we can see like in red, like on top it's like before, and on the bottom it's B5, 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 which is encouraging, I guess. Like we change like one value, so we're seeing that. There's like more than one location that changed, and this one is actually more interesting because there is more to it. and that like mimic what we were like seeing on the like last slide that says, oh, here's the name of the character, and then like line break, and the name again, and like some more like Japanese. So this one is actually like the one where the text being displayed on screen is coming from. So yeah, sorry, I don't have my. So what do we do next? We're going to put a breakpoint on it. So the idea is like usually, more commonly, people know like a code breakpoint, like that triggers when like a piece of code is executed. But you can also set up like memory breakpoints, so that if like a memory location is accessed, it's going to trigger a breakpoint, which is what we want to do here is like locate the code that's responsible for reading this code. So we're going to create like a memory read breakpoint on the location that we've found and see which is the code that does it, that's actually accessing the data. So here's the funky debugger back. If you like lost in the cluttered interface, like the memory breakpoint is like the first orange like thing here, and like then you click on run, which is kind of hard to find. And so yeah, we find like a memory location that's accessing that address. So when we run that like real time, what happens is like every frame of the game, like the breakpoint triggers, but not for all the speech bubbles, only some of them. And we've seen there is like a weird encoding going on. So what we actually have is most likely like a function that's in like the draw loop of the game, so like run on every frame, and that's going to render the text from whatever encoding. So that's cool. But okay, let's have a look to this function in Radar to have something a little more stable. So how we do that? If you don't know, like Radar is like a free software, and it actually handles like PlayStation binaries out of the box, which is kind of was really surprising to me. But I was like, oh, that's neat. And so if you ever put like a PlayStation game in your PC, you would see something like that, where like it's a little cut off, but at the bottom, that's actually like the binary, that's the game. So you can like pipe that into like Radar, and so if you're not familiar with Radar, it's like kind of like the VI of the disassembly world, where like you have a lot of like command line weird stuff. So you can run like an auto analysis to like find the function and whatnot. And something that was useful to me is like you can ask it to display like pseudo text instead of like actual like MIPS disassembly, which if you don't know anything about MIPS is like helpful. So you don't have to learn like a whole set of new mnemonics and whatnot. So we can have a look to like the function that we were like looking at in our debugger. So here's where like the breakpoint triggers, and it triggers. It's like accessing like that, like the memory address at like S0, and we can see that S0 is being assigned at the top of the function. So that might be useful like for later on. And if we look a little down to this function, we can see more processing and okay. So something that's really hard to see here at the bottom, I wanted to share that with you guys. I have like a zoom up version in non-disassembly. So there's just like a little like basic block, and we can see that S0 is incremented, but that's after like the jump, and it's like an unconditional jump. So I was like, what the hell, is like Radar wrong or something? Actually, no, but it took me like a while to learn about that. Anyone knows what this is about? Exactly. So the idea is, yeah, it's hard to see. The idea is some architecture like wants to like optimize a pipeline, and so they like the jump is going to take like more than one cycle to like execute. So there is like more instruction that are fed after the jump that are going to execute it before the jump triggers, and so that's not a bug. That's exactly the way like MIPS work. So yeah, that was like interesting like tidbits I discovered about like that architecture. So we see that S0 is incremented, and that's more the bottom of the function, like in other places where like we also like increase S0 and we test some stuff, and then if the conditions are right, we're going to jump back to like the beginning of the function. which is basically what does that mean is we like actually like iterating through the whole like buffer that we had, and we like some processing are going on. And if we look at some of the tests, there is this like magic values that the data is compared to, like each some bytes are compared to. And if we look back at the memory dump we had, we can see that E7 and FF are like in that dump. So like it's pretty convincing that we like, I mean, looking at the right stuff, and that's this stuff I like meaning. So oops, sorry. So it turns out like E7 would be like a line break, and FF would be like a terminating char, like so that the game knows that it needs to stop processing the string. So let's go back to the plan. We wanted to find text in memory. We did it, but actually there's like a new issue that like showed up, which is like, what the hell is this encoding? So we could do like a bunch of stuff to figure out like what the encoding is like. If we do like BBB, it's going to be like what we have like before. It would turn to B5, and we could like iterate and see like, oh, the letters are what they are. It's keep increasing. Okay. We could also try to modify the memory location and see what happens. Actually, what I ended up doing was like I kind of like I Googled it, and it turns out like this video game is like super popular, and it's been like 20 years. So like a lot of people have been like working on reverse engineering that stuff. And so, for instance, I found that, which is not quite useful because it's the character map for like the English version, but it still like gives like ideas of what's going on. And for instance, we can see that like E7 would be like line break and so on. So and there like much more information on the website about like the structure of the game and stuff. So that was neat to find that. So if we think about it, like what's the font in the game? It's either like something that would be like in the BIOS of the console, and that would just provide like printing capabilities to all the games, or it could be a custom font, and the custom font would be like glyph in memory somewhere. And so it actually turns out that that's the latter. We have like some sprite sheet somewhere that we need to find that contain the font. So let's try to look for the assets and see where the sprite sheets are. So if we dig more into the game, like there's like a lot of these like bin files that contains a bunch of stuff. We can run like binwalk on them, which kind of work. Binwalk is a tool that people use for like reverse engineering like firmwares and stuff. It's it knows a lot of signature of things, and then it's able to parse binaries and say, oh, maybe I found like some zip signature here, or here's a Linux kernel or something. So like here we can see like a lot of JZip compressed data. But I was saying like unfortunately binwalk is a little like confused or something, and it's not doing like perfect job at extracting the stuff. So like by looking at digging it more, it turns out that we find this like structure where we first have like in some of the files there is first a field that says, oh, here's like an entry in the file that's that big, and then like the entry is like a JZip something, so you can carve that out knowing how big it is, and then like unJZip it, and you get something like that, which I think it's the beginning is like a TIM header, which is TIM is like an image format on the PlayStation that I think it was like probably like the PlayStation was like shipping with like an SDK that could handle that, which is basically like an image format, and we don't really want to like implement our own like decoding of TIM, but it turns out that people have done it before. So there is like this awesome TIM to PNG that you can find online, and so what do we find? So here's like some cool stuff extracted from the game. On the left side, it's like a lot of sprites. The color is wrong because I guess like the color palette wasn't picked properly, but we still like recognize a lot of like elements from the game. And what we really care about is like the right side, where there is actually like three like sheets of characters, like the top one, and then like this bottom one, and like the third one. So so it's what we're like looking for in terms of fonts and stuff. So if we look at deep into this like sprite sheet, we can notice that like all the characters are like on a grid. They're like all the same size, so it's like a fixed width font, which is why like it's fine for like the Japanese character because they're like always meant to be like in a same size, but like it looks a little funky with the English characters because like it doesn't handle like kerning where like you'd write some letters like closer to each other to make it look better. But anyway, so as I was saying before, some of the values, everything that's in the encoding, like everything that's below E7 is actually just like a lookup on this like on the first sprite sheet. So like the top left character would be encoded as like 1 and then 2, 3, 4 and so on. E7 is like a line break, and then like in the games there are like these special values FA to FE that would trigger like lookup in other sprite sheets for like kanjis, which are like the most like complicated characters. So here's like just some code for like processing the going through like the encoding. Just like let's move on to like the rest of the content. So the plan was finding the text in memory, figuring out the encoding, but now we want to get the text out of the game. So how we do that? We find like a debugger that we can use programmatically, and then we will like set a breakpoint at the top of the function that we're looking at and read the memory location and get it out. So we're going to instrument that chunk of code. So how so like the PlayStation emulator I was using is like open source, and it has like a built-in debugger as we could see, but there is absolutely no documentation of it. But on GitHub, like in the source code, there is like the explanation of the protocol, which is just like a client-server like communication, where you just like send commands. It's like, oh, set a breakpoint, it's set a breakpoint, and so on. So we can like program the stuff, so it's like pretty easy. We just like set breakpoint. Like I re-implemented like a simple like client that would send the data, send like the commands, read the data, and so on. So that's the first like try. You can see on the left like some debugging thing, and it's printing in the console like some of the text that's on screen. So there is still like some issue. I said there is like we're like looking for like 5 spreadsheets in sprite sheets, sorry, in the game, and we only see 3 of them. Those, but there is like at least like 3 missing. So never mind, that's coming next. Sorry. That's like another issue. So there are like a lot of characters. Like Japanese has like two set of kind of like alphabet plus like all these special characters. So I think in total it's more than 2,000 characters that we're looking at, and we don't really want to like all enter them by hand because we need to eventually we want to convert like something into like Unicode and pipe it into a website, so we cannot just use like just the sprite. So we want to convert them into something more useful, and we don't really want that to do that by hand. So we can like run like an OCR on the data. So the idea is so that's the code again. So because the font is fixed width, you can like split it in tiny chunks and then like run like a tool that's going to recognize. It's meant for like recognize like handwriting or something. And so that's kind of like the output of it. So it's like a little faulty sometimes, but it saved a lot of time because I really didn't want to type like 2,000 characters like by hand and like try to recognize which is which. So yeah, and I was saying just before, something is also missing. It's in this spreadsheet. We've seen 3, but there is like a few more. So where are those? I looked for a while and I couldn't find them, and I was kind of frustrated. So I was like, well, the game knows. So we're just going to dump them. Like the PlayStation has like a VRAM that you can. It's like just like the graphic memory, and if it's printing the characters, they must be in the VRAM at some point. So we can just like dump the VRAM. Yeah, and that's what you get. So it's a little blurry here, but we can see that that's like some of the thing we were like looking before. But on the left side is like the 3 like spreadsheets that were like missing. Here's like with more like that's like more progress with like all the characters like being like implemented. So oops, sorry. So now we got like everything, and we're ready to send the data back into like a web browser or something, and then like use the online dictionary. So let's build it. Here's like a little like crappy diagram of how I built that. So like we're going to create like a WebSocket server that talks with the Python code, and Firefox will connect to the WebSocket server and get the data, and then like wikis is going to translate that for us. So the code, just going to skip it. And let's try to do a demo. Hopefully everything is going to work. So this is like some of my debug view, and this is the game. And here's Firefox. That's not a create interface, but that's it. So we connect the WebSocket. You can see on the bottom it says that the connection was established. And so if we say hi to the guys, we can see here on the left that the text is like showing up in the WebSocket. And wikis is running, so we can be like, oh, what this one mean, you know? And so thank you. So yeah, and we can like keep playing, and there is like still like a few like glitches where like some characters are misrecognized and so on, but it's like it's pretty good, and it's nice. Like if you want to learn like how you see like us or something, like, oh yeah, that's the thing. So yeah, that's kind of the idea. Yeah. So yeah, I think running low on time. So do you have like any questions? Mm-hmm.
How well have you learned Japanese from that?
So to be honest, I made it, and then I was like so tired.